Good afternoon, this is Schweitzer. I'm going to run through some multiple choice questions on Newton's laws and forces. I would strongly encourage you to try a question, pause it, check your answer. Alright, so some of these we have already done in class, or maybe you've seen already, but let's go ahead and take a look at these. Action and reaction forces. So again, this is one of Newton's laws that every action has an equal and opposite reaction. So, alright, so hold on a second here. Alright, so if you have, let's say, a skateboard, and you're pushing on the skateboard, you want the skateboard to go this way, then you got to push on the, you can't push on the skateboard to go this way. You need to push on some other object, like the ground, and push it in the opposite direction. So the magnitude of these forces will be equal, and they'll be in opposite directions, and they'll be on different objects. So that's this answer right here. All right, action and reaction forces. All right, take a look and read these. All right, and again, as mentioned here, equal and opposite direction, right there. Correct that for 1 second. It would be in equal magnitude, but in opposite directions. That's B. Interesting. Okay. Gotta look closely at that. If you don't look close, you'll grab the wrong one. All right. So you are standing on a moving bus, facing forwards, and all of a sudden you fall forwards. Now again, you're on a bus. All right. You, of course, are constantly consumed with your own frame of reference. So the question is that you are on the bus and you think that you are going forwards, which you are, I guess. So is the bus. But if the bus all of a sudden goes backwards or has an acceleration backwards, you might see this as a net result of you going forwards. So really, object in motion stays in motion until acted upon by an equal and opposite force. So in this situation, there is no real force causing you to go forwards. It's just that the bus is slowing down. All right, so you just continue in your motion. Number 4, constant net force acts on an object. Describe the motion. All right, so this is a good F equals ma problem. All right, so F equals ma, and we have a net force, let's just say is x. And if the mass is constant, then this should be a correlating acceleration, and therefore you have an acceleration, which acceleration is going to cause your object to move. So you'll have a constant acceleration. Your speed will going up, your velocity will be going or down, and this is, of course, the same thing as, well, it's increasing, it should be static. A net force accelerates a mass with acceleration of a. If the net force applies to 2m, then what will acceleration be? Okay, F equals ma. Okay, so we're solving for acceleration. Acceleration equals force divided by mass. Now again, some students might like just to put numbers in here. All right, so 1 and 1 would give me an acceleration of equaling 1. So if I double my mass, 1 over 2, then my acceleration is going to be 1/2. That is the answer, which is letter C. And you should be aware that this is just a reciprocal or proportionally reciprocal relationship, where if this doubles, this is 1/2. How would it ever be 4 times? Well, if we're going to be doubling, how do we get a 4? Is if there's a square involved, exponent. So let's say kinetic energy equals 1/2 mv squared. So in this case, if I double this guy, then this guy doubles. But if I double this one, this guy goes times 4. So be aware of that. All right. All right. So we have a 1.5 kilogram ball is kicked and accelerates 4.25. All right. Simple F equals ma question. All right. This is 1.5. This is 4.25. Multiply together, and we get 6.38. Go to the next page. All right. All right, we have 2 forces applied, respectively. They're both positive, so they're both going to be going in the same direction. And you put those two together, 85 plus 52, 85 plus 52.5, and I get 137.5. 137.5, and I have a resistive frictional force, opposite direction, of 45.5, and this is going to give me a net 92 newtons force. The acceleration of a crate if 2 moves, okay, so now this number had to be altered from our original, so make sure that's what you have for yours. So we have a new net force. So we have 100 going 0.2 going this way, plus the 52.5. There we go, 100.2 plus 52.5, and I get 152.7. 152.7. And then the resistive force going the other way is still the same, 45.5 going the other way. Add those two together, so minus 45.5 gives me 107 is my new net force. All right, 107.2 if you'd like, 0.2. All right, then becomes an F equals ma question. F is 107.2. My mass is 175. 175. And we're solving for A. A should be less than 1. There's only one of them that's less than 1. So when I divide out, I get a fraction less than 1. So that's just my answer. All right, the normal force. All right, so again, feel free to pause these things at all times. Normal force. All right, so normally our normal force is if you have a block sitting on its resting force, and if the force of gravity is pulling it down, then the force normal is going up. And the way we do is 90. This will be a hard problem for kids because we do so much where the force normal just equals the force of gravity. Okay, so it's not always though. We've seen some examples where it's not. So it's really a resting force that's just perpendicular to the surface. So if I'm at an angle, for example, and my box is sitting on an angle, the force normal will be going in this direction. So force acting perpendicular to the contact surface, that is what it is. All right, a book on your dashboard suddenly flies towards you. All right, again, this is very similar to the bus question earlier. You are sitting in your car, and the book on your dash flies towards you. It's not that the book flies towards you, all right? Or did you fly towards the book? Really the same thing. So we need this whole car to go forwards, and the book therefore going backwards. So the velocity of the car must have increased or accelerated. All right. On the side note, it's kind of interesting is that if you're in your car and you sit there, and quite often people have a rear view mirror, and they will be hanging things from this rear view mirror. And it could be anything, a necklace or whatever. This is what I would call a working accelerometer. Whichever way this thing tilts, all right, it shows the acceleration. You are accelerating in the opposite direction. So you go forwards, and it will actually tilt towards you. You slow down, it tips back. It's a working accelerometer off that. So it tells you what your acceleration is, or indicates it. All right. So which of the following is incorrect? All right. Of a lot. This is kind of a review question. I'm not sure exactly why this one's on here, but it's a review question. Let's talk about this. So which of the following is correct? And all these are referring to a distance graph. You got to read these. Stop and read them. All right, distance graph looks like this. So it's going to have meters over time, and therefore my slope is meters per time. Seconds. Divide the two out, and the velocity of the slope is the distance. There we go. And finally, our last one. This one is going to. That last problem is going to somewhat help us out with this one. All right. Looks complicated, but let's read it for a second. Again, pausing is the best way. All right. Now, that being said, so this is an F equals MA question. It's telling us that A is 5. And it tells us at time 3 that the force is changing, so the acceleration is changing over time. But the mass is not. So in this case, again, the slope would be newtons divided by time, and you might find that the slope of that is going to be the mass. So in this case, go up here, easier way done would be this guy, which is cutting across, is my correlating force at that time. Again, the force changes, the acceleration changes, but the mass does not. And notice the slope does not change. So this is going to be 15. And then F over A, solving for M, 15 divided by 3. Of course, that we take the newtons divided by the time in seconds. That's the slope. All right? And of course, the slope is equal to 5, which means the mass is equal to 5. All right? Either way, so there's a few ways you can solve this problem. F equals ma is probably the easiest. It might not be apparent right away how a newton and a second can cancel out to mass, but it will. All right, and that should be the end of our multiple choice questions. Thank you.